So this question simply says, which sound has the highest pitch, A, B, or C? And pitch is essentially the same thing as the frequency. And the frequency is a basic property of a wave, which describes how many times a wave passes per unit time. So for example, if we have this wave here, we would have 1, 2, 3, 4 waves pass per unit time, t, and that gives us the frequency. Now we could have higher frequencies, for example, where we could have 6 waves passing through, or we could have lower frequencies, for example, only 2 waves passing through. And as you can see, there's a relationship between the frequency and the wavelength, or this distance from point to point between successive waves. So as the frequency goes up, the wavelength goes down, and vice versa. So if we apply all this information to A, B, and C, we can see a few things. First of all, we can see in B that the wavelength in B is much longer than the wavelength in both C and in A. And if B has the longest wavelength, then it has the smallest frequency, which means it does not have the highest pitch. Likewise, if we compare A and C, we can see the wavelength of C is greater than that of A, and therefore C has a lower frequency and therefore a lower pitch. So we know that A has the highest pitch and is the correct answer. But another way to think about it is, again, in terms of the frequency directly. So rather than determining the frequency as a function of wavelength, you can look just at the total number of waves that pass per unit time, which is the same for each of these. So you can see there are far more waves in A, about 11 waves. In B, we have 4 waves, and in C, we have approximately 5 waves.